Hi class, this video is going to help with section 10.1 and this is our correlation section. So we're taking two sets of data and we're going to make a scatter plot out of them and we're going to find a correlation between the two concepts. All right, so I am going to share my screen real quick and show you guys a little bit of our concept here. So this is 10.1. So the first word I already said is correlation. And when you took Math 1400, you should have done quite a bit of work with the correlation idea. So ours will be a little bit harder. So what is correlation? It's just a relationship between two variables. So for example, maybe it's height versus weight. So we're seeing, is there a relationship between them? Well, yeah, there is. The more you weigh, typically the taller you are. I mean, there are some of us that weigh a lot and that are shorter, but for overall, if you're taller, you typically weigh more. Okay, so that correlation is a relationship. Now, a big idea here is one does not cause the other. We're not showing that they cause anything. So when you're doing your homework, you'll see a lot of questions about that. And really, it's just because a correlation is a relationship between the two, not saying one is causing the other. Okay, then we talk about a linear correlation, which is all we're going to do. I know in Math 1400 you do, that's just, if you're not from my class, that's just college algebra. So if you're in that class, you're doing like a U-shape, that parabola shape correlations a lot in that class. So we're just gonna do linear. Does it form a line? Okay. So we're going to make a scatter plot to see what is that correlation, what is our relationship, and how are we going to measure the strength? Well, let's look at a couple examples real quick from the book. Okay, all right, here's my 4 examples. So we can see that this sort of forms a line on the scatter plot, right? They're going up in a line shape, so it's a positive slope because we're raising to the right. Now this one, we're going down to the left, so that's a negative slope. As one gets bigger, the other gets smaller. As one gets bigger, the other gets bigger for this one. So if we look at this, though, these form more of a line than these ones. So this is a stronger linear relationship. Then if we look at this one here, this one, they're all over the place. They don't even sort of form a line or any pattern. So we say that really has no relationship. And this one clearly is the parabola shape, right? Up, down, around. So it has a relationship, but it's not linear. Okay, so how are we going to know? Well, we can look at our scatter plot and know, if it's a stronger relationship really just by looking. But we also have something that's called our R value, and that's our correlation coefficient. So is there a correlation? And I like to think of this kind of as a percent. Like the relationship between X and Y is about 85%. That's pretty good. This one is a negative 97, even better. And we already said that. We said that one definitely looks like a better relationship than this one, linear relationship. And look, you can tell. It's closer to 1. So these R's are between 0 and 1. And this one here is really close to 0. It's like a 7%, so there isn't really a linear relationship. And this one's stronger than this one, but this is just a non-linear relationship. So there is a relationship between X and Y, it just isn't linear. Okay, so that's kind of looking at your scatter plots and using this R value to decide how strong a relationship is. So R is called your linear coefficient, okay? And if we're 0 or close to 0, there is no correlation, okay? If you are at 1, you're 100%. There's completely a very strong relationship between X and Y, or correlation, okay? So relationship, correlation kind of going hand in hand. Okay, so how are we going to find this R? Well, let's have an example here. So open up StatCrunch. You can pause my video and take a second to do that. And we're going to see that we can find this relationship of 0.795. And this is really going to show us our scatter plot, everything all in one. So here's our values. Pause and put these into StatCrunch. So I'm going to open my StatCrunch right here, and I'm going to put these values in. So we had 5, 6, 4, 4, 5, and the y values, I did the x, now the y are 6, 9, 3, 2, 11. And what we do in here to find this is we're going to go to stat, and we're going to go to regression, and we're going to look at a simple linear regression. Okay, then up here you have to pick your x and you have to pick your y, and we're going to leave the hypothesis at 0 because that means no relationship, and we're trying to show, is there a relationship? So our hypothesis is that there's no relationship. That's kind of the idea here, but we're really not looking quite at that yet. We're getting there, but that is there for further use as well. So here we are. So what are we looking at? Oh, we're given so much information. So up here, we're given the equation of the line of best fit using the least squares idea. And then right here, you have your R. Okay? We haven't really talked about R squared. R squared is the variance. So it's a little bit different. And then this is our correlation coefficient here. So it's 0.795 if we round to 3 decimals. So that shows us we have a relationship. It's almost at 80%. And then in the same one, if you click down here, you can actually see your scatter plot. So there wasn't a whole lot of dots on this one, just because I wanted something I could type. Okay, so here would be what the line of best fit using least squares. That means it is measured to be the least distance from each dot. Okay. It's a specific method that the calculator uses for us. If we did it by hand, it takes a long time. Okay, so other things that we're going to want to be able to find in here are right here, and that's our slope and our t statistic, okay, and our p, which is here and here, always with the slope. We're going to have to find those as well. Standard measure of error might be helpful. Okay, so all in one, excuse me, all in one, we found everything there. And again, we went to stat, regression, and linear. Okay, that's where we went for that. All right, so how are we going to do? I'm going to go over here, and I'm going to move my book. Hold on just a second. Okay, so at the bottom of my notes here that I have, this is straight out of the book. I can't remember if this was a homework problem or I think it might be one of your exact homework problems. So we were given lemon and crash fatality rates. So lemon imports, kind of a strange thing to like, so one's not causing the other. We're just looking, do they have a relationship? So here are the numbers. I put them into StatCrunch. The graph looks like this. So this is a negative relationship here, and they do form a pretty good line. And when I put them into StatCrunch, I got -96. That is a really good relationship. So as crazy as this one sounds, there is a relationship between lemon imports and crash fatality rates. I wanted to do an example of time spent in my math lab on your homework and your test grade, but I maybe in my next video. Okay, so we have our null hypothesis is saying there's no relationship between lemon imports and crash fatality. Then my alternative hypothesis would be, well, we don't equal that, okay? So our significant level kind of looks like this. This means significant is at 0.05. So we go in and we can get our test statistic on that slope line. And this is my test statistic and my p-value. Okay, so I'm not calculating these by hand. Again, in your homework, a lot of times it shows you those by hand. I really want you to be able to look at the graph and say, oh, this looks like it has a relationship that's linear, and to be able to then calculate these using statcrunch, not by hand. You can also calculate the you can use your graphing calculator as well. You might have to watch one of the videos in the lecture on that because it always gives you that one. Okay, so what can we tell? Look, we have 0.0069. That is smaller than this value here. So if P is less than our alpha, right, there is evidence that there's a relationship between the two, which we could already see. Look at it, forms a line. So P is less than our significant, then that means there is a relationship. There you go. What if the P would have been higher? Then there's evidence, right, that the relationship really isn't there. Okay, so that's kind of where you're going. So most of 10.1 is going to be, is your relationship positive? So is it going up? Both of them are going up to the right? Or down to the left, and that's negative. It'll be finding your R is probably half, which we do, and then you'll have questions like this. All right, so hopefully this video kind of helped you with where to go in StatCrunch again. So I'll say it again, stat, regression, simple, linear. Comes up with everything for us. All right, hopefully this helped.